Okay, so we're on to the second pillar of object-oriented programming. The first one was a big one, and that was because we had to learn how to put the structure together and actually build a program. This one is not as big, but it's not exactly small either. These sections shouldn't be small. This is the foundation for the entire course. So it's a little bit intimidating, but keep at it and you will be fine. So what is that second pillar of object-oriented programming? It's inheritance. And today we're really going to be focusing on what this actually means and the ISA relationship, what that actually means. So, as we know, there are three main concepts to object-oriented programming. We've already covered encapsulation, today is inheritance, and in the near future we're going to talk about polymorphism. So what actually is polymorphism? Inheritance. Inheritance comes from the term hereditary, meaning the passing of traits from parents down to children. Now, we're not talking about inheritance in terms of like, ooh, I inherited some money. That's not the goal here. Today, we're talking about more of the biology sense, meaning the physical traits that you inherit from your parents. Things like your eye color, for example. And that's great. Can you think of any other traits that we get from our parents or grandparents even? It goes all the way back, your entire lineage, to your ancestors, because it's something that your great-great-great-great-great-grandma had could actually come down to you. It depends on what that trait is and the biology behind it, whether it was recessive or whatnot. But anyways, of course, there's other things like your height. If your parents were tall, there's a good chance you're going to be tall. Is it a guarantee? Absolutely not. A lot of these things are statistically based, and it just increases your chances of all these types of things. It doesn't necessarily mean that, just because your parents were 7 feet tall, that you're going to be 7 feet tall as well. You could come out at 5'5". It's just the way it happens sometimes. Now, we understand that these physical traits do get passed down from our parents. But what about behaviors from our parents? Do we have any special abilities just because our parents were really good at something? Well, this is actually a very debatable concept. There's actually a ton of examples out there of professional athletes. Let's say, for example, NHL hockey players, where their kids grew up to be NHL hockey players as well. You're talking the top of the top, the best in the world, and then their kids are able to do the exact same thing. So that must mean that it's genetic, right? Well, not necessarily. Now, there's huge examples of the one example is the Sutter family, and which is an incredible thing. At one point, there were 6 Sutter brothers playing in the NHL simultaneously. Interestingly enough, there was actually a 7th brother. And everybody's probably thinking, well, that guy must have got teased at Thanksgiving. No, not really. The rumor is that the 6 brothers consider him to be the best out of all 7 of them at hockey. He chose just to take another path. He became an accountant. So just because you have the ability doesn't necessarily mean you're going to chase that. But it comes back to this anyway. Did they get this ability inherently from parents? Are they just magically gifted hockey players? Well, there could be more to it. It could be things like environment. Did they grow up in a place where there was just a ton of pressure to excel, where the parents just pushed them really, really hard? I don't know. And neither does anybody else. Now, that's not to say that there isn't this thing such as that people have talked about, this thing about genetic knowledge that gets passed down. There's the idea of a savant. A savant is somebody who just naturally knows something without ever taking a lesson. There's tons of examples out there of musical savants, small children that can play the piano and they've never taken a lesson before. Things like that. Like, where does this actually come from? Now, that's another story. However, there is one thing that we cannot deny, and that's the existence of instincts. We all have instincts that are innate in us. So these are behavioral traits that are actually passed down through generations. And humans aren't the only ones that have this. Animals, of course, have this as well. And some of these instincts might just be fight or flight type things, or how to walk and all that kind of stuff. Now, walking, that kind of thing, is usually a learned trait, mind you. Okay, so inheritance. It's all about passing down traits from parents to children. So what does that mean in terms of programming? Well, inheritance in programming is pretty much the very same concept. Now, we're still going to be passing down traits from parents to children, but what we're going to be passing down in coding terms is attributes and behaviors. So we're going to have a parent class, and that parent class is going to pass its traits down to its child class. Now, the thing is, it doesn't necessarily mean it's going to pass all of them. It can, and it probably should in most cases, but it doesn't necessarily mean it is going to pass all of them. So we need to discuss a little bit of terminology going forward, because if you do any research on this, on this concept of inheritance, you're going to see a lot of terminology that we need to be clear on. So whenever you see the term parent class, it can also be referred to as the base class. It means like the foundation. It's the base class. And then you might also hear the term child class be referred to as a subclass. In Java, it actually has different names for these things too. Sometimes a parent class is called a superclass in Java. But we're going to stick with our C# knowledge here. So a parent class, also called a base class. A child class, also called a subclass. Great. So let's use this knowledge going into the rest of our lesson. So the analogy to real life only goes so far though, right? So we have this idea of parents passing down traits and our children gaining those traits. But we got to be careful. We can't let it go too far, because the analogy can get pretty cold pretty quickly, because it's not a very pleasant thing to look at when we actually look at the reality of how it's implemented in code. And I put a note here, this isn't intended to be a joke. It's just the way things turn out, and because this is the natural analogy that anybody who learns computer science inheritance will learn. But I like to spell out the obvious here, just so people aren't, misrepresenting things. First thing, single parents only. Yeah. What this means in most languages do not support the idea of multiple parents of a child. So the traits a child receives will be from their one and only parent. It's not exactly a happy situation, but that's the way it works in coding. So they have one parent who gives their traits to the child. Okay. Estranged children. The parent has no idea that the children even exist. The children have no idea who their parent is. There is no communication between the two in either direction. I'll just let that one sit there for a second. And finally, long-lost siblings. Siblings, or children of the same parent, know nothing of each other's existence. I know this is kind of terrible, but that's the way it works, and unfortunately that's the way the analogy keeps flowing. But anyways, let's move on. So this idea of an is-a relationship, the idea of inheritance, is easy to know if we can make sense of the program. So I'm going to give you a basic sentence, and if you can say this sentence with your structure of base class and subclass, or parent class and child class, then it makes sense. So if you can say your subclass is a version of the base class, then that makes sense. So for example, a cat is a pet. That makes perfect sense. An employee is a pet. That does not make sense at all. So we wouldn't use inheritance in that relationship. Okay, so saying a cat is a pet, that's like, oh, that's a trigger. That's a possibility of inheritance. Now I emphasize the idea of possibility, because it doesn't necessarily mean we have to use inheritance. It's just an option. We may never have the idea of a pet in our program. We just may have a whole bunch of cats and dogs and sheep, snakes, whatever. So here, employee is a part of a pet store program, but it should not inherit from pet because it doesn't make any sense to do so. So use that is a relationship whenever you're deciding whether you should use inheritance between two classes or whatnot. So how does this all work? How do we do this? Well, we start off with a general class. This is going to be our base class. This class is going to define all of its attributes and behaviors just as normal, like it would if it were just an isolated, all in its own class. It doesn't have to do anything special. Well, inside this class, we can designate some or all of the attributes and behaviors to be inheritable to any of its children. So this is clear. We have to be clear on this. Some or all. Most of the time, it's going to be all in terms of attributes. Now, in terms of behaviors, there's going to be some behaviors that aren't going to be inheritable because they just may be public methods. They just may be things that whoever's going to use this class can just use, and it doesn't have to have anything to do with the children. So anything that all the children will have in common, not their values, but the attribute or behaviors themselves, should be designated as inheritable. Now, what do I mean with this? So, for example, some attributes, let's go to that pet store for a second. Let's say we have all of the pets have a name and an age. Those would be inheritable because they all have a name and an age. Even though they're going to have different names and a different age. For example, my parents, they have a name and an age. It's not the same as me. I'm not actually inheriting that biological trait from them, but I do have that trait. I have a name and I have an age. So therefore I would make that as an inheritable thing in my program. Okay, so there is a bit of a disconnect between reality and our programming here. So something like the attributes name and age would be inheritable because the children will have a name and age. Their name and age will just be different. So we then create another class. We have our base class. Now we're going to create another class which we're going to designate as the child class of that base class. We can say it inherits from the base class. So my cat inherits from pet. The child is going to receive all of the inheritable items, so attributes and behaviors, and has the option of adding more data and functionality to itself to make it unique. So if we talk about this pet and cat relationship here, so generic pets, all these generic pets are going to have the same attributes. It might be name, it might be weight, things like that. But cats might have something unique just about cats. Let's say, for example, how high they can jump. That is a unique trait that we don't really track for things like goldfish, right? So it's unique to cats. So we would put that in there as an attribute. And a behavior of that cat might be something that only cats do. Maybe that behavior is walk across your keyboard while you're trying to work. I don't know. Cats are cats. They're not the nicest folk. I'm a cat owner, by the way. So how does it actually work? So for example, we're going to have a base class called pet. This is the example that we're going to be working with today. We're going to have a base class called pet, which has certain attributes such as color, weight, and name, and behaviors such as eat and speak. These are things that all pets do and have. They all have a color, they all have a weight, they all have a name. They can all eat and they can all speak. Great. In this process, we're going to designate which ones are inheritable. To do this, we just need a third access modifier, protected. This is the word we're going to use to designate the fact that that attribute or behavior is inheritable. Protected access modifier, we'll get into that a little bit more detail. Protected belongs to the same family as private and public. We'll come back to that in a minute though. What does it actually mean? Protected means that the class and any of its children have access to that attribute or behavior. So if you create an attribute in pet called color and you set it to be protected, that means pet has the ability to use and modify color. So do any of its children. So cat would have the ability to use and modify that color variable as well, even though it's not actually storing that variable. Pet is. Pet is maintaining that variable. So how does it work? Here we go. So now that we can create any needed subclasses that are going to inherit from that pet class. We have the pet, now let's create the subclasses. So for example, classes called cat and dog, these classes will inherit all of the protected attributes and behaviors from pet. But that doesn't mean they have to use them all. So let's pause for a second. Let's go back and let's go over to REPL and let's start building some of this. So let's say I have this main here. I'm going to add a couple classes in here. So hopefully you remember, we're going to add file. I'm going to add a pet store class. Petstore.cs. Do not forget that .cs, and you have to do it when you create it. You can't rename it, otherwise REPL will not pick up on the fact that you actually created a programming file, not some generic file. Okay, I'm going to create my other ones too. I'm also going to create a pet.cs, and I'm going to create a dog.cs and a cat.cs. So we have all of our files. Great. So we're going to work with the pet, cat, and dog for now, the basic relationships. We'll come back to the pet store and the main.cs later on. So our pet, first thing we want to do is we want to put our using system. We're just going to grab this and put it in all of them so we don't have to keep typing it. Might as well put it in pet store as well. Okay, so now we have to create our class line for our pet. So class pet. And we're just going to leave that right there. And we're going to create a constructor for our pet. So our pet is going to be public. Our constructors are always public. Public pet. And we said earlier that pet is going to consist of 3 different traits. So we said string name, string color, and double weight. So if those are going to be my attributes, I better create those attributes now here. Now, our program said that if we wanted to make them inheritable, we had to make them protected. So my variable, instead of being public or private, is going to be protected string name. Oops. And protected string color. And protected double weight. And just like we did before, we're just going to assign these. So this dot name is equal to name. This dot color is equal to color. And this dot weight is equal to weight. Oh my goodness, can't type. Okay, so we've set that up. You notice I do not have a default constructor. And as I told you during the last lesson, usually you're not going to have one, to be perfectly honest. You're most often just going to have your overloaded constructor. Okay, so we've set that data up. We haven't added any functionality, although in the previous slide, it said that we would probably create an eat and a speak subprogram, or eat and speak behavior inside of here. So we'll leave that just for now, and we'll come back to that later on. Okay, let's go back to our PowerPoint. I'll go back 1 second. Yeah, so eat and speak. So now that we can create any needed subclasses that will inherit from this pet class. For example, classes, class cat and dog, which we already created. We haven't set up yet though. These classes will inherit all of the protected attributes. So right now, cat and dog have access to name, weight, and color. They can just use them like they're actually inside of that class. Without defining them in there. But that doesn't mean they actually have to use them. They just have the opportunity to. So here's the other thing. The subclass has the option of using the base class's behaviors. So anything that's in the base class that's either public or protected, the child class can access. It can use. But it cannot use private things. Private things are still private to that class, whatever class they're made in. Right? So if I make a private method inside of pet, cat and dog don't even know those private methods exist. Okay? So how do we actually use the base class's behaviors? Well, we can actually full-on replace them, which we'll get into later, or we can extend them to be more specific to our own purposes. So for example, we might have a generic display data subprogram inside of the base class, but it's not going to have any of the specific data that's specific to cats, dogs, or whatever animals we have. So in that case, we might use the base class version, but then add on to that to include the specific information for whatever pet we're talking about at the time. So just to quickly go over this, we can simply add more attributes and behaviors to extend, which it makes sense. We can use the behavior of the base class and add more logic to it, which is what I just mentioned. And we can outright replace the behavior. For example, the active speak for dog is going to behave much differently than it will for cat or snake. But that's going to take the next lesson, which is polymorphism. We're not quite there yet, so we're going to skip that part today. So I wanted to talk about this real quickly. Access modifiers. This is the special name, the special term that we use to describe what a class can see or access in terms of a variable or method. So we've already talked about all three of them, but let's define them more clearly. So when you see something that's private, what that means is that only the class that it's defined in can use it. When you see something that's protected, the class that it's defined in and its children can use it. When you see something that's public, the class that's defined in and its children and any other class that has an instance of this class. You can see how this definition gets wider and wider. So private is just the class itself. Protected is the same as private plus its children. And then public is the same as protected plus any other class that has an instance of it. Okay? So if I'm in my main.cs, I can't just use the methods that exist inside of the pet class unless I've created a pet object first. So I have to have that pet object first. Over here, this class diagram symbol, if you recall when we created our class diagrams, they had the three layers, the class name, the attributes, and the behaviors. So for example, in the attributes section, you would define a type and then a name. Well, while we're doing this, we're going to extend that a little bit. And you can actually specify in that class diagram whether you want those things to be private, protected, or public. And that's important when you're thinking about inheritance as well as other things as well. And what you would do is just to the left of the type, you would just put one of these symbols. So if you had a private piece of data because you want to encapsulate it, then you would put the little dash, like a minus sign, and then the type and the identifier. Same as we always would, just with that little symbol. Okay? All right. So now that we know our access modifiers, we can take the next step. Why do we actually want to use inheritance? Is there a point? Is it necessary? Do we absolutely need to? Absolutely we do not. What it will do is give us some perks, some really, really nice perks. The first one is code reusability. If we have less code, it makes the program easier to understand, generally speaking. There is less chance of different and inconsistent implementations of the same operation. Now this is why. Frequently a class is merely a slight modification of another class. For example, if I made a game that had a player and 20 different enemies in that game, but all of those characters moved using the exact same operations and physics, I'd have the same movement code repeated 21 times in that one game, once in each one of the classes. So for example, I might have a game like Fortnite, and you might have all these different types of characters, and even the player, and when you press forward, it gets an acceleration, the player starts moving forward, physics starts to apply, but they all move in the exact same way. Now that's not a great thing. However, we could flip that on its head. If we had a character base class, and that character base class had the method for movement, I could just inherit that method for movement into all of my subclasses that I would have for each of those character types. And then I would only ever need that one code, that one chunk of code. I wouldn't have to repeat it in all the subclasses. And that brings up some huge benefits, such as, well, actually, I'll get into that in a second. But the big one is, like, if I make a change inside that code, all 21 of those subclasses get that change. So if I change the way physics is applied or anything like that, all 21 of those get the update. That's massive. You don't have to make the change. And the bigger thing here is that you can make sure that all of your stuff is consistent. So one change applies to everything. It propagates everywhere. That's a huge difference. So code reusability, massive. Code extensibility. We can extend our code. So fixing a bug or modifying code of inherited behaviors in the base class automatically fixes and modifies the behavior in all of your subclasses, because they all inherit from that one piece of code. Adding inheritable functionality in the base class automatically adds it in the subclass. Adding inherited attributes automatically adds them to the subclass. So what it does is it makes your product more scalable. So you may have envisioned whatever your software is in the beginning to have a set of features, but then maybe your software took off and people started buying it and they start demanding more features. Well, you can't recode your entire program, but if you set it up like this, it's a lot easier to add those extra features in there, add that extra functionality, add those extra attributes with very little effort. But you should realize that you should only use inheritance if it actually offers value to your program, or if you're told to by me. So what I mean by that is, if you're making a game and you have a player and an enemy, and they only share one or two things out of their 30 or 40 things they do, that may not necessarily be a good time to use inheritance. It doesn't really make sense to, right? So you got to look at the situation, analyze it. You definitely have to use the idea of the is-a relationship to make sure that it makes sense at all in the first place. But at the end of the day, it's going to be a judgment call, and does it add value to your program? Will it allow you to reuse a lot of code? Will it allow you to extend your code for the future and things like that? That's the main goal. So let's get to the actual code. Now we already started a little bit, but we're going to come back to this. So we create the parent or base classes as we normally would. We started to do that. The only exception to this is that any data or methods that will be common to it and all of its children must use a protected access modifier. Now I'm going to pause for a second, because this is the part where most students misuse inheritance. They are not putting the right things as inheritable, or they're not realizing what should be in the base class versus what should be in the child classes. If it is shared amongst all of those classes, it needs to be in the base class. If all of those subclasses have an attribute called the same thing, like name, it definitely should be in the base class. If all of those subclasses have a behavior that does pretty much the same thing, it should be in the base class. Okay, that's the key. It's kind of like your general structure, and then everything else uses that general structure and potentially extends upon that. Okay. So a couple example attributes might be like protected string name, behavior, protected, void, do stuff, whatever do stuff actually does. It doesn't really matter. So the child or subclass. So there's going to be two main differences when we create a child class. The first thing is that we have to specify its parent. So in the class line, normally we would just say class and then the name of our class, which is going to be the name of our file. But we also have to designate who the parent is. In our example, it's pet. So let's jump over to our classes inside of our REPL program here. So inside of cat, my class line, instead of the way it is in pet, because pet is just class pet, I need to say, oh, this is a pet, this is a cat, but it's inheriting from pet. So we say class cat, but it inherits from pet. So that sets up the relationship, and the compiler is looking for expectations now. It's expecting you to do certain things, and that certain thing is what we're about to get to next. Now let's set this up for dog as well. Class dog, which also inherits from pet. Great. Now, the next part is it's all about the constructor. What that means is when we create our constructor for our subclass, our constructor needs to call the base class constructor, and it's going to use the keyword base to do that. Now, when I say call, I mean it's actually calling it. So look at the structure here. Public cat, so this is the constructor for cat. This is an overloaded constructor, and it's taking all the properties for a cat: name, weight, and double jump height. Now we're missing one in there too. We're missing color, but that doesn't matter for right now. So name, weight, and jump height. And now look over here. Those aren't variable definitions like they are here. These are actually the variables themselves, because we are calling the base class and we're passing that variable in there. We're passing that data in there because those two attributes in this example are what's stored in the base class, and then we inherit to inside of here. Maybe this will be a little bit more clear if I show you in the actual program. So if we go to pet, we see these three traits, attributes: name, color, and weight. They're part of the constructor for pet. So inside of cat, my cat constructor has to call the pet constructor. Now let's figure out how we do that. So first thing, we do it the same we always would: public, and then the name of our class, cat. And now we have to specify all of our parameters. So we know we have string name, we have string color, we have double weight, and we're going to add one unique one to the cat, which is going to be double jump height. It's getting all funky in here, so I'm going to switch my view to stacked mode so we can see the whole thing. There we go. Double jump height. Now, this is where we actually call the constructor for the base class. This is a little odd, but it happens right on the signature line of our constructor. So we say colon base. That is calling the base class constructor, whatever it's called. All right, because in our code doesn't know. We set it up here so it knows to go to the pet constructor. Now, let's call that constructor. Well, if we look at that, the file, we need to give it a name, a color, and a weight. So we're using these variables. So name, color, and weight. And then we just continue finishing our constructor like we normally would. We have our private jump height, double jump height, which is specific to the cat. So nowhere else has that. So we're taking the jump height that's passed into the constructor, and we're going to store it. This dot jump height is equal to jump height. We are not storing name, color, or weight here. We're not doing that, because when this constructor is called, these three values are getting passed in right here. So it's going to call this constructor, jump over to the pet class, and go into here. And it's going to store name, color, and weight in these variables. Now these are protected variables, they're inherited. That means inside of my cat class, I have access to that data. I can actually display this on the screen here. So I could actually do console.writeLine. I could say, I could actually display name right here if I wanted to. Because this actually occurs before we even get in here. All right, so it happens in order. So we call this constructor. It passes this data into here. It jumps over to pet, does this full constructor, and then comes back to cat, and then it comes inside and finishes up the work. It stores jump height, and then I can actually call this, and it'll work because this is already finished. The base class constructor is already finished. Okay, so you notice that I don't need to do anything special to access that name variable. I just need to just use it. Now, interestingly enough, we came across the this keyword in our last lesson, and this always meant this class. There's another keyword to reference the base class. If for some reason we had two things named the same thing, kind of like here we have this.jumpHeight and jump height, so I can tell the difference between the parameter here and the variable, the class level variable for jump height. We could actually do the same thing with other variables. Say, for example, we wanted to reference something specifically that's in the base class. You can actually use base.name. I don't need to here because that's not what I'm doing here, right? Actually, yeah, I would actually. Because if I didn't do base.name, it would actually use this one, the local variable. So that actually makes a difference. So if I actually want to make sure that I'm using the one that was stored inside of the base class, which might be important to do because who knows what's going on in that constructor over there. We don't know that from here. So maybe it takes that name and concatenates it with something, and who knows. So yeah, so if you want to reference the actual one stored in the base class, you could just say base.name. But if there's no ambiguity, if there's no other thing named name in this area, you could just use the variable name and you'll be fine, the identifier. All right, so we did this for our cat, and we set up the base class constructor and our constructor for this, and that's the whole thing. Let's go do the same thing for dog. So dog, we'll come up, I don't know, what's a unique thing for dogs? They're breed, although there's breeds for other things as well, but nobody really talks about breeds for cats, but they definitely talk about breeds for dogs. So let's say we have a private string breed. You'll notice this is not protected. I'm making this private. Now you might say, can I make it protected? Yes, you can. Because believe it or not, you can have children of children of children of children of children. So I could have something that inherits from dog. I don't know what that would be, but I could have something that inherits from dog. That's pretty interesting because they would actually get the inherited traits from dog and the inherited traits from pet. So the inheritance actually goes down the family line. This is pretty important because of that multiple levels of inheritance, you may find something quite useful. Okay, let's do the constructor for our dog. Public dog, and we have string name, we have string color, we have, what did I say, double weight, and string breed. We need to call the exact same constructor for pet we did before, so it required name, color, and weight. I just realized that my furnace turned on. Hopefully that's not coming across the mic, but it probably is and ruining my last 35 minutes of video. But let's find out. Okay. What do we need to do in here? Not much. We just need to store this breed variable so we don't lose it. This.breed is equal to breed. Boom. All right, so we've set up the basics. We have now made the connection between our subclass and our base class by stating who the base class is, who the parent is, and calling the constructor for the parent. Those two things are the absolute requirements. There'll be more requirements in the next lesson when we start talking about polymorphism, but right now, those are the only requirements. So let's hop back to our PowerPoint real quick. So we've done all this. That's great. Now let's put it all together. Where do we put it together? We put it together in the driver class. Now, I'm going to go over the next two slides, and then I'm going to show you a full example that's doing everything at once. So in the driver class, you can create instances of any of the children, or the base class, as you would in any project. You don't have to do anything special. You just create instances of them. However, creating an instance of the base class, you almost never do it. Why would I ever create a generic pet? It doesn't make any sense to do that. You can't then redefine it later on. That's not the way things work. So the idea of creating the pet, yes, it's physically possible, but there's not a reason to do that. Not that I can think of, but I'm sure somebody comes up with something, but it doesn't really make much sense in my point of view. So if I had like a pet, I could create a pet who's called generic pet, and I could just say new pet. Now this would be doing a default constructor for pet, which we didn't create, so that would cause another problem. Cat1 is equal to a new cat named Fuzzy, who's 5.8 pounds and can jump 3.2 feet. Now look at this. Now I have an array of dogs, array of type dogs. Now I've created it to be a size of 3. There's no dogs in this array. This is just a container that can hold 3 dogs. Think of it like a kennel. Now I can add a new dog by saying dogs at index 0 equals new dog. Fido 48.3. Oh, I forgot my breed there. I'll come back and I'll fix that example afterwards. Here, let's put that in there right now. Let's say this is a, what's a good breed? I can't spell Chihuahua, so let's say lab, generic lab. Okay, great. I don't like this generic pet, but so let's put some things in here. So this pet can be, I don't know, Bill the pet, who is, we definitely did not, I did not create these things the way they're created in the beginning, so I should have a color for all these as well. They're all going to be brown. And how much does Bill weigh? Bill weighs 23.2 pounds. We better put some colors in here. Oh my goodness, what is going on? All right, manually typing it is. And there we go. Now it's all fixed up, so it should match everything else that we do. Great. So these examples actually make sense now. Sorry about that. So we're looking at all these things. So we can just create these. And now we can start using them. So I can start doing things like cat1 dot whatever the cat can do. Whatever. We haven't actually set up any behaviors yet. So we should probably do that. So here's a practical application, or the idea of a practical application. If you're building a pet store application, which we plan on doing, how do you store all your animals? Do you store them as an array? An array or a list of each type of pet? So do I have an array of dogs, an array of cats, or a list of dogs and a list of cats? What if you want to carry a new type of species? What if you all of a sudden are also carrying birds or fish? That means you're going to have to go back into your code, add another class, and then you're going to have to create another array and maintain and go through all your code through your entire program and maintain how you handle all those arrays. That may or may not be an issue. Depends on the way you set up your program. So if you create an array or list of the base class type, which you can do, you can actually add objects of either the base class or its subclasses to it. So look at this example. I created a list of type pet. Okay? And now I'm adding a cat to that list of pets. That's perfectly allowed. There's nothing wrong with that. I could also add dogs to my list of pets. It'll accept them. Now, there's a problem, though. When I go to pull those pets out later on, when I go to pull that cat out, so let's say I try and access element 0 of all pets, what's going to happen is it's actually going to come back to me as a pet. It still has all the data and structure of a cat, but the program thinks it's just a generic pet right now. So I would have to do a little extra work. I can actually check its type with the is keyword. And then I could do some casting to actually apply any of its behaviors. So for example here, I say if all pets 0 is cat, then I'm going to cast all pets 0 to a cat. Notice the brackets around that whole thing, including the cast. Then I can call any cat-specific behaviors. If I didn't do this cast and I tried to call that cat behavior, it's going to fail. It's going to say this thing doesn't exist as a pet behavior, because it thinks all pet 0 is a pet. So There's definitely a downside to keeping track of this list of generic pets, which isn't really full of generic pets. However, we're going to fix all of that and make all that hard work go away as soon as we learn polymorphism. So it's a downside for now, for about 2 days. Okay, so let's go back over our program. I'm going to show you a fully functioning working REPL that has everything done in it. So let's go through here. Here we go. So this has everything. I haven't documented it yet because I wanted to keep the code pretty small, relatively speaking. So let's take a look at what we have. We have our main.cs, and I'll come back to this in a second. But what you can see this main.cs is doing is it's creating a pet store named Petorama. It's going to display all the pet store information, which I put in as a behavior for the pet store. It's going to add a dog. It's going to add a dog, a cat, a dog, a cat. So it's adding 5 pets to the store. Then we're going to display all the pet store details again, so we can see that it's actually added those pets. And then we're going to we're displaying all the pet details. Then we're going to display all the store details again. And then finally, I'm calling some generic method that tells all the pets to speak, to see what they say. We'll come back to that. Down below, I'm doing some other specific stuff. We'll come back to that in a minute too. Lots of coming back. So let's go look at our structure. Let's look at our pet first. So inside of our pet, I've added the 3 inherited values that we've been talking about before, but I've also added another one called species, so I can keep track of whether it's a cat, dog, or whatever, but only for display purposes. So here we have name, color, weight, and species. Great. I've also created accessors and modifiers for everything, accessors for all of them, but only modifiers for name and weight, because I can't change my species and I can't change my color. At least I shouldn't be. Don't dye your pets, please. And then I've created 2 public subprograms, 2 public methods called eat and speak. Now these are public. So that means anything that has an instance of a pet or any of its subclasses can just call eat or sleep. Or sorry, eat or speak. Not sleep, speak. I purposely put this pet colon here so you know that this functionality is happening from the pet class. And then down here I have this protected subprogram called display data. It's protected, which means the only thing that has access to it is this class and its children class. So the outside world cannot call display data. You might be thinking, well, that's kind of useless. Why wouldn't you? Well, we'll get into that. So let's go look at a dog. So the dog is much shorter in its size. So first up, it only has one unique attribute, which is a breed. I know this looks funny, but it's just because we don't have enough visual space here, horizontal space. But anyways, so we have this dog, and we've already set this up. You've already seen how this is. There's no difference here other than the fact that I put the species in here and I put it as a text value of dog. Why? Because I'm creating a new dog. And then accesses modifiers, but only for the breed, because all the other things are already taken care of inside of the pet class. I don't need to create accessors and modifiers here because this one isn't handling those. Pet is. All right. Now I created this public function called speak. This creates problems because pet also has a public function called speak, or a public method called speak. So which one does it use? When I create a dog, does it use the dog speak or does it use the pet speak? Well, it's going to use the one that it's directly associated with. So it's going to use dog. If dog for some reason doesn't have a speak command, it's going to look in the pet class, and then it'll use that one's version. But this isn't actually something that we necessarily want to do for now. So now normally you would say, well, just make the dog go woof. Why not? Well, because we're not there yet. Polymorphism is going to allow us to do that. It's also going to allow us to make our cats go meow. But for now, all of our animals generically speak and say hi. Except for the fact that this dog is saying, no. I want you to say this junk instead. Okay. Now down here I have another public subprogram called display dog data. Now this one is using the idea of extensibility. What I mean by that is it's actually calling that protected subprogram that was in the base class called display data. So this shows you that we have direct access to that from this class. So it's calling the protected display data, which is right here, protected. And then I'm saying, okay, show me all of the generic data. Now add in the breed, please. Which is why when we go and see the output over here for Scooby-Doo, we get the breed attached at the bottom of it. And it looks like it's all one cohesive unit. That's the idea anyway. And cat is just more of the same. So cat has one specific attribute. I called the constructors for both. I did the accessor for accessor modifier for get and set of jump height. Nothing special there. I have the display cat data, just like there's the display dog data. Nothing special there. But I did add one special subprogram that only the cat can do, and that's jump. And he says, whoopee, I jumped however many feet high. That's specific to a cat. Great. That's about it. Pet store is just kind of like the overarching thing that owns all the pets. Now I implemented it both as arrays, separate, like a separate cat and dog array, or a single list. So right now I have the arrays commented out, and I have the list doing its work. If you want to switch it over, comment out all the list stuff, and then make the arrays do all the work. So yeah, and that's everywhere. You can see where the comments are. So let me show you what this does. So let's look at the list data first. We have a list of all pets, and we're tracking how many cats and dogs we have separately. I don't necessarily need to do that. I could technically go through the list and count them as I go by type, but that's a lot of work when it's much easier just to maintain the two values. Okay? I have a constructor for my pet store that just takes a name for the pet store itself. I have two functions, two methods, one to add a dog, one to add a cat. Now you see the difference here. If I'm using the list, I just say the list.add and I create a new dog. If I'm using the array, it's dogs at however many dogs I've currently have so far equals a new dog. Same idea. And then I increment the number of dogs. Cats is the exact same plan. Nothing special there. Okay? You can see when I defined the data structures up here that I set it to this constant max pets by type. That was just so I could use that number elsewhere without dealing with magic numbers. Magic numbers are evil. So what do these functions down here do? Display all pet details. They look longer than they should be. Now if you look at the array version of it, it just goes through two for loops that says display the dog at I, display the cat at I, calling their individual types. So this is important because display dog data is very different than display cat data, right? They have to do their specific ones, and each one of those is in that type of class. So if I tried to call display dog data on a cat, it wouldn't work because that method doesn't exist inside of the cat class. It's not there. Okay? So these ones are very straightforward. This is actually pretty easy. When we have a list, oh man, this complicates things because you have to know what type of class it is so you can call the correct version. So that's ugly. So first thing I have to do is I have to detect its version. If all pets at I is a dog, then cast that pet to a dog. Because remember, when we bring it out of this pet list, it thinks it's a pet. Really, it's a dog, but it thinks it's a pet. So we have to cast it to a dog once we've realized it is a dog, and then we can call the display dog data information. Just the same thing as we can with a cat. Now I used an else if instead of an else because just in case I wanted to add more types of pets in here, I could just add more else ifs. Okay. Now, again, when polymorphism comes into play, this is all going to get shrunk down into one single line of code. But we got to get polymorphism going first. We're not quite there yet. And then so that's the display all pet details. And the all pet speak does the exact same thing, except instead of display dog data or cat data, I'm just saying display speak. Now, because our dog has that special speak in there, I still separated it based on which one we're doing. Okay. I have this question here. What happens if we don't cast, since they're all pet type? What's going to happen if we just do this and comment out this stuff? We just have all pets at I.speak. Try and think of it for a second. Pause the video, and try and think of what you think will actually happen. Okay, hopefully you're back now. So all pets at I.speak, well, what it's going to do is, because it thinks it's right, all of these are pet types, it's going to use the pet version of speak. Remember, the only reason it uses the dog version of speak here is because the dog actually has a public speak method. The cat doesn't. So it's actually going to look in the cat class for a speak method. It's going to say, nope, not one there. So it's going to go into the base class version and say, ah, there's one. I can use that one. This is probably not desired behavior, though. Again, polymorphism is going to save the day. Great. And then finally, all display store info does is just display the basic stuff. And again, there's a specialty here because whether you did it by arrays, if you did it by arrays, you just need to add up your number of cats and dogs. If I did it by the list, I can just do the allpets.count because it's a total number. Great. So that's everything. That's a lot. There's a lot going on here. And you may want to just sit and go through this code for a while and try and take your time and step through it piece by piece. I'm going through it fairly quickly here. Now, let's go see how this is all tied together. So in main.cs, let's follow this code. I'm going to run the program so we can see everything going. I'll move this bar over here a little bit. So let's watch how this works. It says, clear the console. That's just so we can get a nice clear output. I created a pet store named Petorama. I displayed the pet store info, which is right here. Petorama has 0 pets in total, 0 cats, 0 dogs. And then I created 5 pets, 2 dogs, a cat, a dog, a cat, in that order. And that's very important to realize that. Okay, now let's go back over to the pet store for a second, because when we call add dog or add cat, we have to realize that when we come in here, it's actually running this logic. Okay, for us right now, it's just adding it to this generic list. Otherwise, it's going to add to the array of dogs. So that's the way it works. Then right after that, we're saying store.display all pet details. So it's jumping back to the pet store, and it's displaying all this. So it's going through, and if it's a dog, it's going to call display dog data. If it's a cat, it's going to display cat data. And it gives us these 4 lines. Okay? So what does that mean? Well, let's go over. Let's say it comes in here and it does it. The first one is calling display dog data. It's going to go to the dog. It's going to go down to display dog data. This one's going to say, oh, do the base class version of display data. So it jumps over to pet, and it writes these 4 lines of code. A blank line, the name and species, the color, the weight, and it's finished, so it comes back to dog. It's now done this line, and it outputs another line for the breed. So that's how we get all 4 of those lines. Scooby-Doo, who's 123.8 pounds, is brown and a Great Dane. So then it comes back to main.cs. And, sorry, I lied. It comes back to pet store. And it goes through and it does the next pet, and then the next pet, and then the next pet, till it's all out of pets. There were 5 pets. And they got displayed in the same order that they were added. 1, 2, 3, 4, 5. So we got 2 dogs, a cat, a dog, and a cat, which was the same order that we added them in here. Now, if you use the array version, you wouldn't get it like that. Because if you use the array version, you see that we're doing all the dogs, then we're doing all the cats. So you would get dog, 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 cat, cat. So it does create different results depending on how you do things. So it does make a difference. Back to main.cs. So we displayed all the pet details. Now it's just going to display the store info again, which is this one. It displays the name of the store, how many total pets, how many dogs, and how many cats. That's fine. Now the speak one is one that I really want to look at. When it calls us allpets.speak, look at the output here. Because the first 2 are dogs, it's using that dog version of speak that says this method hides the pet.speak method. Not necessarily desired, need polymorphism. You'll see why soon, but basically it's going to call the correct version of a method when it needs to based on its type. That's what it boils down to. And then the cats all get pet high, and that's because they don't have their own version of speak. Okay, let's comment this stuff out for a second because I want to demonstrate something. Now we can play around and do some just generic things. Now, normally, one second. Normally, I'm building a pet store and I'm doing all the stuff via the pet store. But just for demonstration purposes, I'm actually going directly to the pets themselves and creating individual pets. I'm ignoring the pet store. We're just throwing them out there like animals, okay? So I've created 3 pets. I've created a cat named Cat1, a dog named Dog1, and a pet named a pet. So this is just a generic pet. Create an instance of a pet class. Why? Demo only. Don't create an instance of a pet. It doesn't make sense to do so. Okay. We have a cat, a dog, and a pet. Now I just go through some basic operations for each. Let's run this program to see what we get. Let's analyze it. So the first thing we get is a cat and a dog. Something is going on here. No, that's right. And we also get this guy down here, which is the pet. So let's look at this. We created a cat, and we said display the cat data. So we got Kitty's cat details. Color black, weight 17.2 pounds, jump height 5.5 feet, which is everything we set there. Great. Then we said cat1.eat. Well, cats don't have an eat function at all. So it says I don't have one, so it jumps over to its base class, which is pet. It says, there you are. And it's going to use the pet version of eat, which is why we get pet. Yum. Now it says cat1.speak, and it does the exact same thing. Cat doesn't have a speak operation, so it comes back into pet, and it uses pet hi. Wait. Sorry. Go back. What did I do wrong there? Oh, sorry. There we are. I was looking at the wrong one. Yes. Got confused. Yes, pet hi. That's what it should be. And then we call cat1.jump. Now this is important. The cat does have a jump operation. It does have a jump method. So when we go into the cat, it comes in here and says, whoopee, I jumped 5.5 feet high. Okay, great. So the cat's done. Now what I wanted to show you is, what if I called dog1.jump? And I tried to run this program. Immediately it fails because it says type dog does not contain a definition for jump, and no extension method jump of type dog could be found. Are you missing an assembly reference? It basically means dog1 doesn't have jump, so stop trying to use it. That's pretty important. Okay, let's go down to the dog now. The dog does the same thing. Let's rerun the program so we can see everything. So the dog does the same thing, outputs its 4 details. Great. Dog1.eat. Dog doesn't have an eat subprogram, so it goes to the base class and says pet yum. Dog1.speak. It does have one. It shouldn't have one, but it does have one. And it overrode, basically. It said, no. We are not going to use that one in the base class. We're going to use this one. Now you see we get the warning up here. It says dog.speak hides inherited member pet.speak. It's inherited because it's public and, well, we have access to it. Great. Now, this generic pet here, it can only access things that exist only in pet, which means I can do eat and speak and they'll work just fine, yum and hi. But as soon as I say try and use something that's in one of the base classes, or sorry, one of the subclasses, I get an error. Does not contain a definition for jump, obviously. Display data does actually exist in pet. However, it's protected. And this class here, main.cs, has no access to this. Okay? We cannot call display data from here. Cannot access protected member pet.display data. Not allowed. So we can't do that. So this is the entire this is an entire inherited setup program. What we're going to do is when we learn polymorphism, we're going to use this exact same program and we are going to fix it up to properly use that idea and that strategy. And you're going to see how the code cleans up and tightens up really quickly. But just like inheritance, polymorphism isn't necessarily a required thing that you need to do. Okay? So that's the entire lesson. That's pillar number 2 down and another hour of video. Hopefully you got what you needed to. Come back and watch what you need to if it's a necessity. use the PowerPoints, and get into the practice work. Good luck.